Welcome back to Come and See with Miss Hasty and Math Expressions, Lesson 7-4. We are going to split this lesson in 2 lessons. So we're going to have part 1 today, and then part 1 will be the next video. And then along with that, so we'll be doing 2 pages in your activity book, page 291 and 292. And then I'm going to go over the 7-4 remembering side. And that will be your homework for this particular lesson. And then part 2, you will do the homework side once you have completed the rest of the activities together. All right, so we are going to begin on page 291. So turn to 291 in your activity book. And today we're learning about patterns and expressions. Okay, read along with me. So that comes up. Oopsie. Okay, a numerical pattern is a sequence of numbers that share a relationship. Each number in a numerical pattern is a term. Below, we show the first 5 terms of a pattern. Okay, here we have 3, 5, 7, 9, 11. Obviously, that pattern is odds. Those are odd numbers. The pattern above starts with 3, then each term is 2 more than the previous term. You can write a numerical expression for the terms. We show 2 possible expressions for each term below. All right, so for example, we have 3, 5, 7, 9, 11. And these are expressions that show the same, an expression that equals that number. Okay, so 3, 3, and 3. 5, another way to express 5 is 3 plus 2 using the pattern. Or 3 plus 1 times 2. Okay, for 7, 3 plus 2 plus 2, or 3 plus 2 times 2. Okay, for 9, 3 plus 2 plus 2 plus 2. If you add that all together, you get 9. Or another way to show it is 3 plus 3 times 2. So we have 3 2's there, 3 times 2. And 11, one way to show 11 in an expression is 3 plus 2 plus 2 plus 2 plus 2. Or 3 plus 4 times 2. Okay, 4 times 2 would give you 8, plus 3, that's 11. All right, so let's look at some of these together, and if we can figure out the next term. So number 1 says, write 2 expressions for the next term. The 6th term, because we already have 5. 1, 2, 3, 4, 5. So think about what would come next. All right, we're going to actually do B first, because what would come next? If you're counting by 2's from 3, 13 would come after 11. So what's another way that we could write that? Okay, one way we could write it is 3 plus 2 plus 2 plus 2 plus 2 plus 2. Okay, so 5 2's. Or 3 plus 5 times 2. Okay, there's our 5 2's. That's one way to write it. 2 different ways to write it. Number 2, let's look at another one. Write the first 5 terms of a numerical pattern that begins with 5, then adds 5. So if you start with 5, what would the first 5 terms be? And then add 5. That's our rule. Start with 5. If you add 5 to 5, you get 10. Add 5 to 10, you get 15. Add 5 to 15, 20. And it says the first 5 terms, so we need one more. Add 5 to 20, 25. B says write an expression for the 6th term of the pattern. So here's 5. So what would be the 6th term? If we kept going, the 6th term, 25 plus 5, would be 30. That would be the 6th term. So what would that look like if you wrote that out? One way to express it, 5 plus 5 plus 5, and how many would you need? You would need 6 of them to equal 30, right? Plus 5 plus 5, okay? Or another way to write it would be 5 plus 5 times 5, okay? And 3, write the first 5 terms of a numerical pattern that begins with 1, then adds 8. Okay, so always start with the first term. That would be 1. I'm sorry, did I say 8? I meant 9. Then adds 9. So if you start with 1 and you add 9 to 1, you get 10. If you add 9 to 10, you get 19. Add 9 to 19, 28. Add 9 to 28, 37. Okay? And you can do that off to the side if it doesn't come just to your head. Okay, then B, write an expression for the 6th term. Well, if we added 9 to 37, the 6th term would be 46. Now, what are 2 different ways we could express that 6th term? Always start with the number you're starting with, 1 plus, and then 9 plus 9 plus 9 plus 9 plus 9. 5 nines, right? That would be your 45, 46. Or 1 plus 5 times 9. Okay, again, you can write times with the dot or you can write times with the X. Okay, let's go ahead to page 292. Look at some more patterns and relationships. Okay, number 4. Write the first 5 terms of a pattern that begins with 2, then adds 2. It's basically counting by 2's, right? So, 2, 4, 6, 8, 10. Starts with 2, adding 2. B, on the next line, write the first 5 terms of a pattern that begins with 4, then adds 4. So 4, and then I add 4 to that, 8. Add 4 to that, 12. Add 4 to 12, 16. Add 4 to 16, 20. Okay, C says, circle the corresponding pairs of terms in the patterns. How does each term in the top pattern compare with the corresponding term in the bottom pattern? So, first we're going to circle the corresponding terms. That means the top number and the bottom number. We're going to do that for each one. Then we're going to look at the relationship. Okay, how does the top pattern compare with the corresponding term in the bottom? Well, the top number is 2, and the bottom number is 4. So the top term, make sure I am at the same place here, is the bottom term, okay, divided, see, sometimes it's writing for me and sometimes it isn't, divided by 2. So the top term, which is 2, is the bottom term, which is 4, divided by 2. Okay, so then if we look at the bottom term compared to the top term, it would be the opposite. So the bottom term is the top term times 2. Okay? Looking at the relationship, the top term, which is 2, is the bottom term divided by 2, and that goes all the way across. So 4 is 8 divided by 2, and 6 is 12 divided by 2. 8 is 16 divided by 2, and 10 is 20 divided by 2. But then the bottom term is the top term times 2. So 2 times 2 is 4. 4 times 2 is 8. Okay? All right, number 5. Write the first 5 terms of a pattern that begins with 9, then adds 9. Again, we're writing our 9 multiples. Okay? So we start with 9, and then you add 9 to 9, which is going to be 18. So that's 9, 18. Add another 9, you get 27. Add another 9, you get 36. Add another 9, you get 45. Now, write the first 5 terms of a pattern that begins with 3, then adds 3. Well, 3, you can count by 3s. 3, 6, 9, 12, 15. Circle the corresponding pairs in the patterns. We're going to do the same as we did above. Circle the top number and the bottom number. And then how does each term in the top pattern compare with the corresponding term in the bottom? The top term, in this case, is 9. The top term is, it's going to be the opposite of up here, is the bottom term times 3. Okay, so top term, which is 9, is the bottom term 3 times 3. So then the bottom term compared to the top term would be the opposite. The bottom term is the top term. Bottom term is the top term divided by 3. Okay? If you didn't have a chance to write that down, you can stop the video and take some time to write it down. Okay, number 6. Write the first 5 terms of 2 different patterns. So we get to choose one. Let's go ahead and just do a simple start with 1 and add 1 on the top one. 1, 2, 3, 4, and 5. And then the bottom one, let's start with 10 and add 10. 10, 20, 30, 40, 50. Again, look at the corresponding terms. Describe 2 different relationships that the corresponding terms of your pattern share. Well, let's look at the top term, which is 1, is the bottom term divided by 10. And the opposite, the bottom term is the top term, and we go to underneath here, times 10. Okay, looking at patterns and relationships. Alrighty, as I stated in the beginning of the video, we're going to split this into 2 parts. So that is all the class activities we're going to do today. Now you're going to move on to 7 for remembering. And let's just go over the story problems so we make sure we know what the equations are and review some of these problems. Okay, 7 for remembering. Number 1, Manny has 40 ounces of butter that he is cutting into 1.25 ounce slices. How many slices will he have? What is being split up here? The 40 ounces is being split into, or divided into, 1.25 ounces per. Okay? So, division with a decimal, and that's going to tell you how many slices he will have. That will be your label. Number 2, Tracy is running in a 5.25 kilometer race on Saturday. A marathon is approximately 42 kilometers. How many times as long as Tracy's race is a marathon? Well, this is one of those where it's kind of a situation equation, and then to solve it, we're going to figure out the solution equation. So 5.25, how many times to equate to a 42 kilometers? Okay, so when we don't have one of our factors, we're going to take our product to solve this and divide it by the factor we do know. And that's going to give us our unknown. Okay, and how many times as long? That's going to be your label. Times as long. Write an equation and solve the problem. Use mental math or estimation to show your answer is reasonable. Okay, well, we're going to estimate here. So the story problem. Each Saturday morning, Janie works 5 hours and earns $35.75. How much does Janie earn for each hour she works? Well, we know how much she makes. And we know how many hours, so we're going to divide that by 5 to figure out how much she earns for each hour. Okay, and your label is going to be money. So when we estimate, we round our numbers. So what would you round 35.75 to? And 5, you could keep it as 5 because that's a nice round number. And then when you divide, your answer here and your estimated answer should be close. And then you know you're correct. Okay, 4 through 9 are a review of what we did in 7-3. So using order of operation, go ahead and solve these with the number that you can place in. Okay, so for this one example, you're going to rewrite it because you know what t is, and then go ahead and solve. And number 10, create your own numerical pattern like we did on our activity today. Write the starting number, the rule, so what are you adding each time in the first 5 terms in the pattern, then write an expression for the 10th term. So look back at the activity we did today to help you with that. Okay, so that concludes part 1 of 7-4. Again, we will be doing part 2 on the next lesson. Okay, have a great day.